Hi, my name is Jerry Palmer. I'm a research scientist with Qubit Systems in Kingston, Ontario, Canada. I'm here in a field in the north part of Fairbanks, Alaska. The reason I'm here is to test the new methane sensor that Qubit just made. And I have with me in the field one of our soil respiration packages. We call it the QSR1LP. These packages consist of a weatherproof case with several modules, 4 to be exact. They can be pumps, flow monitors, gas sensors, whatever. This particular soil respiration package has a pump, a flow monitor, an RH and temperature sensor, and an infrared CO2 sensor. These are replaceable, so they can be switched out to turn the package into a useful instrument for other experiments, such as small animal respiration, human respiration, photosynthesis, nitrogen fixation, and so forth. So I'm here with this package. The data I've collected, I've actually replaced the flow monitor with a O2 sensor and the RH monitor with a methane sensor. And that way I could measure all 3 gases: oxygen, methane, and CO2. Now, I'll talk about 2 types of gas respiration measurements. First is the soil efflux measurement. This is accomplished by having a chamber placed on the ground. You leave it some minutes so any disturbance of the ground wears off. We pump gas from the chamber, dry it, and push it through the gas sensors in a closed loop. And that way we can measure the 3 gases that diffuse out of the soil. So you initially place it on the soil, let it rest for a couple of minutes, then do the measurements. Then the measurements can be repeated by flushing with air, putting it back on the ground, and repeating the measurements. The data is collected on a laptop using Logger Pro software. The actual data for the 3 gases is obtained from the slope, the initial slope of the gases when the chamber is first placed on the ground and data collection begins. As I said, the instrument can be portable and run in the field for up to 6 or 8 hours on lithium batteries. In addition to methane measurements, which I was easily able to measure coming from the soil near ponds, I was able to measure the methane in water from the pond. And what I did here was take a liter or so of water. Actually, in the case of the pond, it had so much methane that I only needed 50 mils. Okay, but in a lake in the Fairbanks area, I would need about a liter. You pour this into an empty jug, shake it so that the gases in the liquid equilibrate with the headspace. Then you place the chamber, the jug, in an open loop configuration and pump the gases through the analyzers, and thereby obtain the concentration of oxygen, methane, and CO2 in the headspace gas. From the headspace concentration, you can back calculate using Henry's law for dissolving gases in liquids. You can use that law to back calculate the actual concentration of the gas in the liquid. So I was able to easily measure methane both in the water and in the soil around these methane ponds. Just as an aside, I was also able to measure methane in human breath and also in cockroach respiration. So the system should be useful for physiological studies. Now I'd like to just show you the amount of methane that's in these ponds. As I said, I'm in a field. This is a hay field. It's obviously been deforested many years ago, and the permafrost has melted, and actually the ice wedges have melted, causing depressions. These are shallow depressions which fill up with water. They have a lot of carbon in the bottom, almost like peat, and being shallow they warm up, so the bacterial activity is quite high. I actually measured water temperatures earlier in the summer up to about 23-24 degrees Celsius. So these methanogen bacteria in the bottom, in the sediment, in the absence of oxygen, produce methane, which can either dissolve into the water slightly, or more likely escape to the atmosphere as bubbles. Now I'll just walk out into the pond and show you the amount of bubbles that are coming up. You can see as I walk, there are gas bubbles rising. This is methane. Sometimes little fountains, especially earlier in the summer when it was warmer, little fountains of gas would last 2 or 3 minutes. And using an inverted funnel that was filled with water first, you can actually trap these gases and then light them with a barbecue lighter, and you get quite an impressive little explosion. Apparently methane burns when it's in the concentration of about 4 to 15%. So obviously there's a lot of methane in these ponds. Although the ponds themselves aren't all that big, these thermokarst ponds, there are a lot of them, and they contribute a fair amount to the methane budget in the Arctic. They also, methane is also released from beaver ponds and swamps in more southern latitudes, and I hope to test this when I go back to southern Ontario. So in conclusion, it appears that the new qubit sensor, in combination with the CO2 sensors and oxygen sensors, can tell you and provide quite a bit of information about these 2 greenhouse gases that are so important in this age of global warming. Thank you very much.